So welcome everyone. My talk is best recipes of bringing machine learning to Elasticsearch. Guys. Mhm. Brilliant. Let me shortly talk about my company. I'm quite sure that most of you used or at least heard about eBay. eBay is a mother company of eBay ClassFit Group, and we have a lot many businesses which are rated not on worldwide as eBay, but on local markets. We have so-called horizontals. These are very similar to eBay companies. It's like Kijiji in Canada, eBay Kleinanzeigen in Germany, Marktplaats in Netherlands. And also we have verticals, very specialized platforms. For example, for auto dealer, we have Mobility in Germany, Kijiji Autos in Canada. We also have Motorco UX, which we bought not long ago. And personally, I work for Mobility. So our mission is to connect sellers, car buyers, and we give cool experience of buying and selling cars. So we are biggest guys in Germany in this business. We work with 40,000 dealers and have like over 1.7 millions of ads. So search is our core functionality. So that's how it looks like on the website. And if search doesn't work, we don't have any business. So it's very saint, very cool part. But till very last time, it was super straightforward. Everyone mostly used price sorting. So user just see everything sorted by price and had to set up number of filters to slice it down to see some reasonable events. So he had to filter by car type, mileage, engine, color, whatever. It's all cool, and from one side, simple approach is cool because user understand how to use it, dealer understand how to be on the top of search result page. All you need is provide best price in your category, and you on the top, everyone sees you. Problems that world goes to get, and you cannot expect in 2020 to be successful without smart stuff, without recommendation, relevancy, personalization. Everyone expects that all online selling platform now personalized, smart, they know what you want, they can predict your behavior. And that's why 2 years ago we had to sit and think, what can be perfect solution on our platform? Let's take an account and how we want to see it. What should we care about? Of course, we have to take into account user preferences. What users looking for? Is he looking for BMW or Audi? Is it family car, small, big one? Maybe it must be red, green, whatsoever. It should take main attraction factors. For example, is rating of dealer you buying from good? So did he had good feedback from user where he's located? Is it opened when it's convenient for you? You have to take into account kind of ads. Is it a good ad? What's price? Is it good in your category, bad in your category? There is also business pressure that dealer has different accounts. They also buy paid features. You can pay and be on top of the page or be more relevant or be premium dealer, and then you have to get more share. It all looks cool, but at that point we also realize that it will be like more than 1 year project and it's everything scope. So problem was not so much technical, but even management, organizational. How can you convince to change such a core functionality in the long run and succeed with it? So there are two ways how you develop. Either you work waterfallish, let's say, when you have big plans ahead of you, you plan, you prepare, you build it for a long time, put a lot of resources, and in the end, yes, you have a fancy, awesome, nice car. Problem that risks are high, maybe car is wrong, And my personal problem is that no one gives me 2 million for such a project. Maybe managers are just greedy bit. And opposite, you can approach it very agile way. You say like, okay guys, I'm not going to build fancy auto for you, but I can build in 1 month bicycle. It will serve your business purpose. It will improve some of your business metrics. And you gain some belief to me. If it works ahead, I already have knowledge, I have experience. I can build motorbike, I can then build car. Of course, then the overall way is longer, but results are much safer. And cool that if you stop at the middle because of stop funding, in first case you will end up with half of car, which totally useless. It's like legacy code in the scope of your systems. And in second, you end up with some motorbike. It's not so bad, not legacy, gives some value. So at that point, we decided how can we start build smart products on the platform, which was super straightforward. Even it's huge business. Everything starts with user tracking and profiling. You have to know who are your users, what they're looking for, and what can you show them. And exactly that's how we implemented it. Oh, cool, I have Ponder. So every user which iterates our platform, which inside is cloud, fancy microservices, tons of front-end services, but each user has to have a visitor ID cookie. As soon as he comes to our platform, if it's logged in user, we derive this cookie from his user ID. If he's not logged in, then we should just generate a DOM alphanumeric. And whatever action he does on our side, his visitor ID always propagated downstream to any service you have. So like all backend services get it. And then they generate events. It can be like add view, car buying, contact dealer, whatever you can imagine what user can do. It's everything ends up in event collector service. So service is supposed to grab by HTTP tons of events, bit convert them and put into Kafka. In general, we have about over 300 million events per day, like 1.5 terabyte. You can argue that, okay, it's not big data, comparable small, but still events are very valuable because it's not selling some small stuff for €1, it's selling car for 10K or maybe 20, it's very useful. At the end, it goes through enrichment. For example, in some case, you want not only know which ad was viewed, but all attributes, what car it was, all information about dealer, for example, which rating of this dealer was. Everything lands up in Hadoop. We have fun handling PI, hash data, take care about GDPR compliance, and once again store in Hadoop for long life. So as you see, there is an icon on the top, which signs that, yes, there was no business value. It's exactly our preparation step which we have to take. But from this point, we could build real-time user profiles, which we hope to then use in search and be really fast and use for personalization. So we grab Kafka, where we already have user activity events, and with Spark, you save running aggregations for every day, for every property of viewed ads. You just have all the statistics, and you save history for last 30 days. Fun was that in Cassandra, we fight a lot to make it really fast. So because we had a window like 20-30 milliseconds maximum to give a response. And it turned out that if you have history of 30 days, it's quite a big chunk of information. And bottleneck here is even network capacity of a single node. So we end up that we have partitioned end by user and by date, and having 30 nodes in our Cassandra cluster and running 30 queries in parallel and then merging results end up in much better performance. And then it's everything available by HTTP, and That's very simple UI. We can say what's first user profile look like. After this, you know that guys looking for used cars, half BMW, half Audi, you know models, you know all car attributes, and where he looks, and tons of another information. And now you can be personalized. First, we decided to create recommenders on our systems, and that is how. You have usual search requests as always, which then been enriched with user profiles. In Elastic, you can simply say that if a document matches your criteria, you put extra weights. And for example, we use 7 or 8 main properties like color, engine, and whatsoever. And you can say that if car matches most preferred color, it has extra weight like 4. And then if you were looking for green BMWs, you on all recommenders will more tend to show you green BMWs afterwards. Quite straightforward, quite nice, and as you see, it was first bicycle. It was very important to show exactly company and management that yes, we can deliver. That's how, that's first tries, and we have lots of ideas. So we learned how to make tracking, how to work with Cassandra, how to work with Elastic, put weights, and that was first step in building this system. And after it, we showed business metrics in growing demand, because if you don't have any recommenders, it's always better to have at least some, and earned some business belief. What could be next step? We were sitting and just checking what's not cool at our site. And yeah, can someone say that which car offer is obviously better? I think not immediately, right? Same Mercedes, similar model, similar mileage, similar age, price is totally the same. You have to dive into description. You have to read, check, and think and compare what's better, what's not. I can guess this would help you a lot. Simple recommender, which will immediately tell you if it's good, not good price, and provide you with some kind of recommendation. How can you do it? As always with machine learning, all you need is you have to know your history, your events, your inventory, your data to predict. And after some analysis, you build machine learning model, and from it you can run predictions. We apply it same way as we used to our customers to track our ads. So on each change of ad, they at the end of the day will land in Hadoop with all the properties and the exactly price. And data scientists run cleanup, exploration, ETL, and at the end land everything in H2O framework. If you didn't try it, it's really cool machine learning framework with huge advantage from TensorFlow, because these guys are very compatible to Java instead of TensorFlow tends to be very Python guys. And at the end, it produces a simple zip file which you can just load in your Java application in one liner. And this model is being saved in cloud storage. Problem here is how can you squeeze machine learning in platform? Imagine kind of legacy platform working with simple relational database, and you don't know from which side you should go into it. What we've chose? It's having a price evaluation service, which on startup just loads from cloud machine learning models, and it's ready to serve everything just from startup by HTTP. And on all updates to any ads, they go from database owning service, which first saves ad in database, and then also forwards request to price evaluator to get price and also put it in database. So challenge was also to make it really fast. So how can you make your prediction run from 2 to maximum 10 milliseconds, having our machine learning model sometimes are 4 GB size. And on the top of it, you have to imagine that JSON, which describes ad, is quite huge. It's like over 100 fields, over 100 properties. It has tricky structure, and machine learning needs totally another format. So you run tons of ETLs. So it was a lot of fun. I had to write some DSL with translations of all these fields. Navigation was very similar to Mongo, so if you have included structure, you just pay everything in dot. And I ended up with very long response time, just because JSON's library is really slow for navigation. So advice, if you need really good throughput in navigation ETLs, don't use JSON libraries. Convert everything by the most Java JSON into map, and having included maps, just navigate through them. In Scala, it took like 14 lines of code. And after it, response time dropped down from like around 100, 200 milliseconds to around 2-3 milliseconds. So, and at the end of the day, everything will go to Elastic. We will have our prediction. We can show them on the site as I already showed you. So what we've gained is we achieved really awesome technical solutions that prediction run in only a few milliseconds. And when we just want to recalculate price of every ad on our platform, I tried and I got on 3 microservice instances with like minimum technical requirements over 1,500 evaluations per second. And it was architecture where you can easily squeeze new machine learning solutions in scope. A bit problem is that it will not scale so well, so you can put, because you multiply number of writes to database, because on every ad update you make now 2 writes. If you have 3 services, it will be 3 writes and it will grow. But it will be a point for next conversation when I present architecture to solve it. But at the moment, we can imagine that we have, yes, customers exactly were super happy with our solution, and dealers were super angry. You can imagine, I was contacted for a dealer and he said like, man, I'm super angry, you get a very red label for me, but I'm trying just to sold my Volkswagen Polo for 12K. And I said like, seriously, it's more expensive than new one. And yeah, I got ended up that you can in Germany sell everything, but you're breaking my business. Maybe it's exactly what we want, because in our platform we want to have belief between users, buyers, dealers, between everyone. And when someone tries to screw someone else, it's exactly when we, by goodwill, have to take actions. So now we can come back to our puzzle, which we already had. We have all parts together, so we have information about price, we have information about user, dealer, but how can we cater it all together that it serves our purpose? In general, we have like over maybe 40, 50 parameters. It depends on the point of view. And it's already too much that you cannot do it manually. You cannot go into Elastic and say like, okay, color is important, it has weight 5, and dealer rating is even maybe more important, it has weight 10. Problem that it's not so much true, because for some people, dealer rating is super important. He wants to buy only from trusted dealers, and from someone else, he wants lowest price and he will just buy from private sellers. And that's, we just got into computerial explosion. The complexity of solution is so high that you cannot sell manually, you cannot squeeze new features. You have to go with machine learning approach in a higher level. You have to always search, be somewhere smart, but you have to choose good solution. Good solution is, I can highlight 3 of them. Either you have machine learning plugin in scope of Elasticsearch. Advantage there is that Elastic is very well-known technology. Everyone works with it, we use it since many years. It's already in the use, so you don't have to convince management or whomever to switch technologies. which is super hard, and company which makes many millions of euros from them. And disadvantage that you have to support this plugin. It should be part of all deployments. Ops will get crazy. When new Elastic comes to be deployed, you need to compile new plugin. It's quite headachy, and also, as I will show or tell, that productivity of this machine learning plugin is highly varies between minor or even minor Elastic versions, not even saying about majors. Also, you will hit limitation of machine learning libs because you can go only with that only library which is packed in scope. On opposite, you can take Vespa. Vespa is intended for machine learning. It's a friend for TensorFlow, but it's so new and hard to migrate to that actually even after having some workshops and proof of concepts, I cannot convince my management that we have to switch. Or I have to take responsibility for all search platforms, which no one's give to me. Last step, you can have your custom services. You can imagine that when Elastic returns you number of results, you just have to reshuffle them to make them somehow better. But problem here is that you can apply machine learning only to one page. So if your page is 20 items of size, maximum which you can optimize is only 20, which maybe on other positions were something more relevant. And also problems that you introduce new latency. Plus one guy in the middle, plus one HTTP request is always bad, it's always penalty. And not surprising, we chose Elasticsearch plugin. How it works? It was learn to learn plugins, and main idea that, of course, if items more relevant for user, they should go on top. The more relevant, the higher they are. Many companies, like for example Get Your Guide, they hire people to mark them manually. So someone really sits and gets, okay, this is query, dinner at Eiffel Tower. And please mark that this item, which is actually dinner, is very relevant, and item that it's only cruise by Sen, it's not so much relevant. We could not, of course, pay people so much to sit and click on our Mercedes and give us relevancy. We were looking for good learning criteria. What can we choose to apply machine learning? And not bad criteria was actual view event. So if user sees some ads in the list and clicks on it, it's already sign of relevancy. You can argue that it's more probability of click and it's maybe depends on eye catcher and or quality of photo of the car much more than on exact relevancy, but still it's very good learning factor. Mathematically, it looks like you have a number of parameters from x1 to xn in which you encode your user profile data, exactly parameters of your ad, parameters of your dealer, so you have quite many of them, and outcome y is exactly Boolean, was it clicked or not clicked. It all goes to learning systems, produces model, and model used in ranking system. And in ranking system you just on input send data in same format, same ad, user, dealer, whatever you want, and an outcome you get prediction, which is probability of click. And you would like to order your result sets depending on probability of clicks. Here you will face second problem, that machine learning is quite heavyweight. You cannot have million of ads and on each user search request run through all the million and give good results. You cannot even apply good filters and slice everything, for example, for white Volkswagen Golf. It still will be like 100k of results and your machine learning still will fail. Your user will wait for half an hour. Fortunately, Elastic provides us really good functionality called rescoring. So you're still able to run query exactly as it was before, but you can say that for rescoring you use 100 best results on your found result set, And you can apply a machine learning model to only this result to reshuffle them. Also, you can provide scripting fields. Example that machine learning has sometimes problem working with booleans or whatever string values, and I couldn't pass truth or false in scope of library. I had to translate them into zeros and ones. Same goes to ETLs of float values. For example, in machine learning, you never use car mileage directly because it's a very high number. You take logarithm of it, and etc. and etc. It tends to be comparable expensive, and to prevent such transformation, maybe we will index such possible known features in the indexing time, not in runtime. And looking on the big picture, now you can see how it all works together. So first, we enrich our ads with everything we can know in indexing time. So we can calculate price rating, we can enrich it with dealer ratings, with whatever transformation factors, and we put it in Elastic, which has LTR plugin. And when anyone runs search, we take his filter, his criterias, and enrich with his profiles to make an already quite relevant result set, which with query, exactly user preferences and ML rescoring comes in scope of Elastic. In Elastic turns that having user weights, preferences, whatsoever, we prepare quite big, very already relevant result set, and on top of it, run a prediction model which says on which of this ad is chance of clicking is highest, and based off it we get our result set. Highest question now, we touch on very core functionality, very important one, and we have to definitely prove that we don't hit response time, we don't cause any technical problems. It's all must be stable, reliable, supportable. I had some fun writing a load testing tool for it. If someone used Kotlin, did anyone? Then I highly recommend. It's a really cool Scala tool, which really helps you to stress your system by the high load. So what tool just was doing is, if you give it, intention was, if you give your tool any Elastic cluster, it should immediately tell you what will be response time and if you can use it for production or not. So you have to automatically create indices, generate ads, upload machine learning model, and stress it hard to see if it can or if it cannot hold the load. Also, big question was to check that your results are consistent. Because imagine that someone just puts parameters in the wrong order, and yeah, machine learning will always answer you with some value. It's like 0.5. What does it mean? Is it right or is it not? So we had to build second pipeline where we invoke machine learning library directly and check that results of Elastic and from pure machine loading really work together fine. I passed very basic testing, for example, in Elastic with cluster with one node, 500,000 ads, and got really nice pictures, looks cool, is all response time with division by P50, P99 whatsoever. And the result was just promising, I would say. So of course we had penalty. Here I compare outcome without model, with using simple linear model, which, okay, it's very basic, but only to proof of concept. And with already comparable smart lambda mart model with 16 features. If you look inside, it's somewhere around 16,000 lines of XML packed as decision trees inside. And penalty was not so bad, so it was 10 to 20 milliseconds. And we found out that essential part of this time is spent on ETLs, so on translations is falses to zeros ones, taking logarithms and whatsoever. So we can improve it, having already pre-indexed features. And also on new Elastic, this test was running at 6.4.2. And on Elastic 6.7, we saw that it behaves much better. So penalty was much closer to 10 milliseconds, which is already really cool, and you can just get it compensated by scaling your cluster. So outcomes was that we have all infrastructure in place. We have huge learnings what we can do with Elastic, and maybe our operation guys already hates us because migration from Elastic is always a pain, and migration of Elastic plus plugin is not even double, triple pain, especially when you touch prod. And business outcome is not proven yet. We're supposed to run A/B test in some next weeks, and we'll see how conversion goes up or down. We already proved it to Elastic with user preferences without machine learning model, but putting machine learning on top is exactly our concern now. So as a summary, I would say that if you approach big projects, big topics, you have to try to break it into smaller ones, and exactly not from technical perspective, like from technical perspective for engineers it's super easy, but you have to slice them on business perspectives. Don't forget to deliver MVPs, simple projects which pursue business values or show any metrics. At least it's super important to show in big companies. And data is always your source of whatever machine learning you have to run, because as soon as you have any data, you can run many predictions. And regarding machine learning and Elastic, I cannot say that putting machine learning in Elastic is really cool. I would highly recommend, as long as you can, pre-calculate your results and only final results of your machine learning store them in Elastic. You will not pay extra penalties. You will still have very simple search engine, and it will be still fast. If it doesn't work this way, like, take step back. Use machine learning to build smart queries. For example, if you have free text input, then put effort on analyzing it. But like, don't hurry to put everything machine learning plugins in Elastic. You start to pay very high penalties. Its problem becomes very, very complex and very hard to solve. We just didn't have any other choice but moving ahead. And in some weeks I will be able to share maybe more results. Thank you.